First, we will need a Raspberry Pi 3 and a controller ULN203 APG, a stepper motor, and a van. I will use this, and a board to put our work on it. Red pins or wire and blue and black, as you can see. Now we will need yellow wires and blue and pink and green. As you can see, I am using a wire of one input and one output. That's why I am using two wires of the same color and a board to make a full line. As you can see, I have the Raspberry Pi 3 in my hand, and there it is, pins. Now I will show you the map of the pins. You can see the map here. This is the side, and this is the same side that I draw. However, you can see that the red circles are the 5-volt pins, and the blue circles are the GPIO pins. The black circles are the ground pins, and the blue X is the 3.3 volt pin. Now to the numbering of the pins. We can number this 1, 2, 3, 4, 5, 6, and to the last one. Now to the map. You can see the map here. For this experiment, I will use the Python code and the Java code. You can see the Python code here. Here we imported time and rpi.gpio, and here we put 7 and 11 and 13 and 15 as A, B, C, D. It's actually the pins of the Raspberry Pi 3. However, here are the pins of the controller, and we will use it as the picture shown above, from A to D to the right side. So the right side will be from A to D. Like it's shown here in the code to the right. You can see this code will let the stepper motor to the right. So the stepper motor will move to the right because as you can see here, we have a hexadecimal numbering, 4 number. Every number is for A or B or C or D. The first one is the A, and the second one is the B, the third one is the C, and the fourth one is the D. In the first step, you can see all of them is zeros. Only the A is 1. Here is the A is 1. The second one, the second step, you can see it's going from the A to the B, and that's why we need to make the two of them, A and B, make them 1. So we will put 1 in A and we will put 1 in B, and the others will be zeros. So it will move to the from the A to the B. The third part, the third step will be it will be in the B. So it moved from A to B. It need to be stopped in the B then it will move to the C. As you can see, I have put only one here, and it's actually only in the B. The others are zeros. To move it to the C part of the circle above, we need to put in the other step one in the B and one in the C. And it's go like that to the last step. You can see this step. All of them is 0, but the D is 1. That will stop in the D. But we wanted to make a full round, so we will need the stepper motor to return to the A, and that's how we'll return to the A, make the D 1 and make the A 1 and the others 0. It will leave the others and move from the D to the A. For the left side, you can see it is the same hexadecimal numbering, but the opposite. So it is starting from the A to the D, then to the C, then to the B, then it's returned to the A. Our map is work by moving from step to other step. But when it's moved to the other step, it will be stopped there a little while, then to be moved the other step. Then we will complete the code. You can see here that we have put a 2038 to the left and a 5000 to the right. That we'll see it in the actual moving of the servo of the stepper motor. Sorry, about 1 second from now. Now for the Java code. Thanks to this guy on YouTube, he helped us a lot. But there's something with his code that we didn't take, because he used this controller and we don't have this controller. Actually, we have the ULN 203 APG controller, so our controller is different completely. We used the same mapping we used with the Python code, so there's no different. And we used this code here. We didn't use it all. Actually, we have taken the code and built our own code from it. So very thanks for this guy. Now for the code, if you can see here, yes. You can see here that I opened the Raspberry Pi on the LCD, the Raspberry Pi on the LCD, and I have opened from menu program to the Guinea programmer's editor, sorry, and a new project with Java. You can see that the guy on YouTube has imported the libraries here to use it with the GPIO. He imported the libraries, then he put the 4 pins of the controller here. As you can see, the 4 pins of the controller that is communicate with the 4 pins of the hose Pi. So this is the same controls to make the servo move around himself, right and left, and there is you can see he make it be forward for 2 seconds for 2038 step around. That's make it 2 seconds for the right and 5 seconds for the left, as you can see. And this is how will the motor will stop. That is our code. Now let's see how the motor will work. To see the motor working, I will just put my device here and make it work. Just a second. As we can see, it's working right now. This is the motor. Yes, this is our motor here, as you can see. Yes.